Hello y'all, Clifford Campbell here, and today we're doing 3.3 Pythagorean Theorem. Okay, I feel like students are pretty good at Pythagorean Theorem, and my students don't typically say that they see too many Pythagorean Theorem type problems. So let's walk through. Now, what I wanted to start with is I feel like with Pythagorean Theorem, you would get a lot of simplifying these square roots. Okay, we call it simplifying radicals. These things are called radicals. Now, so let's go through it, okay? Now, in order to simplify a radical, what you actually have to do is, I'm going to start with this one right here. You have to do what's called prime factorization, which means that every number, any number that you ever have, you can break up into prime numbers multiplying. And if you're like, what the heck is a prime number? Okay, let's write down the prime numbers real quick. 2, 3, 5, 7, and it goes further, right? You know, you can have an 11. It's any number that is only divisible by 1 in itself. So if you think about that, like 2 can only be 2 times 1. You can't make it any other way. The only way to make 3 is 3 times 1. The only way to make 5 is 5 times 1. The only way to make 7 is 7 times 1. You get the idea. And it goes on for forever, okay? But these are the ones that we're probably going to be focusing on, or probably these first 3. Probably not even that. Probably not even 7. But so we're going to break these numbers up into these things. So let's look at this. So I want to break it up into prime factors. So every number can be broken up into prime factors. So here's how I do. 16 I can do as 2 times 8. Yeah? Now 8 I can do as 2 times 4. 4 I can do as 2 times 2. Now, the reason why I chose this one is I think we all know what square root of 16 is. It's 4. Now, the reason why I wanted to do this one is because now I can show you why it comes out 4 with this prime factorization idea. Okay, so 16 is basically 2 times 2 times 2 times 2. And if you want to check that, you can go in the calculator and double check it, you know. But 2 times 2 is 4, times 2 is 8, times 2 is 16. Now, what this prime factorization does is there's a little thing on the outside of this radical. There's a little 2. Now, it's imaginary. It's kind of like how when you write x, you don't put the 1. Okay, when you write square root, you don't put the 2. Now, sometimes they do put like 3s and 4s and stuff like that. That's to let you know that it's something other than 2. Now, so what we're going to do is, since there's a little 2 here, it says, oh, we're going to group things up into 2. I like to say, oh, they're couples, you know? They're couples. They love each other. These twos love each other. And then once they love each other, they move outside of the house. Yeah? So what I did was I moved the 2 out, and now I got 2 square root of 2 times 2. And there's still a pair of 2's, right? So these 2's can move out of the house as well. And when they move out, they multiply with that one. So 2 times 2 is going to make 4, which we already knew it was 4. So let's try this method out on some that are, you know, a little more complicated, like 45 or something, okay? So let's break this up into prime factors. So we're going to see what is it divisible by 2, 3, or 5, maybe 7. I don't think they're going to go past that. But let's see. Yeah, it's definitely divisible by 5, right? 5 times 9, right? Okay, and then 9, well, 5 isn't divisible. That's a prime already. 9 can be rewritten as 3 times 3, which both are primes, right? So I can, the square root, 5 times 3 times 3 is 45. 5 times 3 times 3. So notice I just rewrote 45 as 5 times 3 times 3. Then you're going to look in there and you say, okay, is there any couples that I want to take out? So there's 2 3's. I'm going to take those out, and they come outside, and it's 3. And then this 5 has to stay his lonely self inside of the house, you know? So that is square root of 45 rewritten, simplified. So if you ever do these Pythagorean theorems and you get an answer of like square root of 45, they're probably going to put it as, you know, the answer is something like that. So you need to be able to simplify. So watch, I threw some variables into these ones just to make it even, you know, different, okay? So let's prime factorize 24. So 24, it can be 2 times 12, right? 12 can be written as 2 times 6. 6 can be written as 2 times 3. Okay, so I can rewrite square root of 24 as 2 times 2 times 2 times 3, right? 1, 2, 3. 3 2's and 1 3. And then we also have 2 x's in there. X squared just means x times x, right? You see where I'm going with that x squared thing? Okay, so I can find my 2's. There's a pair of 2's there I can take out, and there's a pair of x's I can take out. So now outside of the house, I'm going to have a 2 and an x. Inside of the house, I'm going to have a 2 and a 3, right? And they're multiplying, so I can just multiply them already if I want to. And there we go. That's this rewritten in simplified form is that. Okay, let's do this 108. And you know what? I don't think I have enough space. 108x cubed. Let's do it down here. 108x cubed. Okay, so I'm going to break it up. 2 times, let's see, that would be 54. Okay, I can break up 54 and 2 times, let's see, 20, why am I drawing blank here? 27, right? 27. And that one I can break up into 3 times 9, right? And that I can break up into 3 times 3, right? Here, I'll erase that. 3 times 3. Okay, and then I got 3 x's in there. So I can rewrite this whole thing as 2. How many 2's are there? 1, 2. There's 2 2's in there. There's 1, 2, 3 3's. So 1, 2, 3. Okay, and then I got 3 x's in there. I can multiply the 3 x's in there. Okay, so I can combine these, come out of the house, and I can combine these and come out of the house. So that makes 2 and a 3 outside of the house. And then we're left with this 3 inside of the house. Oh, look, we got a couple of x's that can come out. So I can put an x there. And there's 1 x that was left in there. So let's see here. 2 times 3 is going to make 6x, square root of 3x. And that is that rewritten. Okay, now let's just do Pythagorean Theorem real quick. I feel like a bunch of y'all know the Pythagorean Theorem, okay? And there's a pair of, there is a pair of, not a pair, but a few different ones that people usually remember. So like, let's say you have 3 and 4, and I say, figure out the hypotenuse here. Okay, well, Pythagorean Theorem is a squared plus b squared equals c squared. And it's only useful if it's a right triangle, okay? So right triangle means a 90-degree angle right here. Okay, and then let's figure this out. Now this is always, the long one is always your c, okay? And these, you can call them whatever you want. A and b, it can be b and a, it really doesn't matter. But let's go through this. So 3 squared plus 4 squared equals c squared. And here I'll put an x there since that's what I called it over here. Okay, 3 squared is 9 plus 16 equals x squared. This is 25 equals x squared. And then we just square root that to figure out what it's going to be. And when you square root, remember it gives you a positive and a negative version, right? But we're not going to have a negative length, so it's going to be positive 5 is going to be our answer right here. That's going to be the length right here. And this thing, when they all come out as integers, like real nice numbers, no decimals, no fractions, those are called Pythagorean triplets. And there's a couple of them. There's 3, 4 with a 5. And there's a couple more. You can look them all up. I don't think it's really going to help you on the test too much if you know them. But another common one is 5, 12, and 13. Okay, with that being your hypotenuse. Okay, let's make one up with random numbers. Let's say we got a length of 6 for one of the legs. Let's say that I know the hypotenuse. Let's say the hypotenuse is, I don't know, 15. And it says solve for that. Okay, so I'm going to use a squared plus b squared equals c squared. Okay, remember, this is my long one. That is c. So I'm going to do 15 squared here. And then b squared, I'm going to say that's my x. I'm going to solve for x. And then this will be my 6 squared. Okay, you just go about solving here. So this is going to be 6 squared is 36. Plus, here I'll call it x squared, equals 15 squared. Let's write that out. 15 times 15. It's going to be 225. Okay, we need to solve for x, right? So we're going to subtract off 36 from both sides. It's going to leave me with x squared equals, okay, 225 minus 36 is going to be 189. And we just square root that. Okay, square root that. And we're going to say, okay, well, so then x is equal to square root of 189. Now, that looks like you would probably be done, right? But we can break this apart. Let's see here. Let's prime factorization this. So 3 times 63 would be 189. And 63 we can also break up into another 3. So 3 times 21. We can break that up into 3 times 7, right? So let's write this out. Rewrite it as 189 is going to be 3 times 3 times 3 times 7. Okay, and do we have any couples that we can put together and move outside of the house? And we do. We got a 3 that can come out. Now that 3 and the 7, they're both still lonely on the inside, so I'm going to multiply them and leave them on the inside. 3 times 7 is 21. And there would be my answer. That is the length of right here. It'd be 3 square root of 21. Okay, and that's Pythagorean Theorem. I hope it all made sense. Y'all have a great day. Next, we're starting up chapter 4. Adios.